Hello, I'm Jeffrey Sutton, and our problem today is that a solid circular titanium control rod at 7,000 pounds axial tension force stress must not exceed 42,000 psi. You have to assume that the modulus of elasticity of the titanium is 16,500,000 psi, and that the rod must elongate no more than 0.20 inches. Determine A, the minimum rod diameter to a precision of 0.00, and B, the maximum rod length to a precision of 1. Now, first, we must state our knowns and our unknowns. Our knowns, as you can see here, our force is given 7,000 pounds. Our stress is given, which is 42,000 pounds, psi, Our modulus of elasticity is 16,500,000 psi. And our elongation is 0.20 inches. Now, the problem asks for us to find diameter and length, both of which will come in inches and are known as our unknowns. Now here are the equations that we must use to complete this problem. We must find area, that way we can get the diameter, which is stress equal to force divided by area. Now once we get the area, we must use it to find the diameter, which is area equal to pi times the diameter squared divided by 4. Now, that will give us our diameter. So that means that we have one of our problem solved. But we must get the length. And so, since we found area in the first problem, we can use it in this equation here, which is elongation is equal to force times length divided by the area times the modulus of elasticity. Now, to help us out here, maybe we should draw a picture. So as you can see here, we have our titanium rod showing how it is elongating by 7,000 pounds of force. Now it's time to substitute and solve. Don't mind just I pull up a chair to help you further see this. Substituting, solving. So our first step, we must know what our equation is and restate it. So we restate that stress equals force divided by area. Now we simply plug everything in. So you get 42,000 equal to 7,000 divided by A. Now we must multiply by A, which will then give us 42,000A equal to 7,000. That's step 3. Now, for also part of step 3, we have to divide by 42,000 to isolate the variable A. So 7,000 divided by 42,000 gives us approximately A is equal to 1/6 inches squared. Now, with this, we must use A, or the area, in our next equation. So you have A equals pi times diameter squared divided by 4. And now we just substitute everything in. So we put in 1/6 equal to pi times diameter squared divided by 4. Now as we did in step 2, we must divide by the denominator, which is 4. So we're going to have 4 multiplied on both sides, which gives us 2/3 equal to pi times the diameter squared. Now, to isolate the variable, we must divide by pi, giving us 0.21 inches equal to diameter squared. Now, to get rid of a square, we have to square root the problem, which gives us the diameter being equal to 0.46 inches. And notice how I went to the precision of 0.00. There's 3 places there with a decimal after the first. Now, to solve this, we must finish with problem B. Now, here we have to rewrite our equation, which states elongation is equal to the force times the length divided by the area times the modulus of elasticity. And when you plug everything in, you get 0.20 equal to 7,000 times the length divided by 16,500,000 equal to multiplied by 1/6. Now, 16,500,000 times 1/6 comes out to be 2,750,000. And as we did in the previous problem, we must isolate the variable by multiplying by the denominator. So we multiply 2,750,000 by 0.2, and that gives us 550,000 equal to 7,000 times the length. Now when we divide by 7,000 to isolate the variable L, we get L equals 79 inches, which is to the precision of 1. So that's all. Thank you, and I hope you had a very solid time.